Hello friends, we have already discussed about how to determine the adjoint of a second order matrix through the conventional method. The conventional method I refer to is first finding out the minors, then the cofactors, then the transpose of the cofactor matrix. Here I am going to show you a shortcut trick to quickly determine the adjoint of a second order matrix. Okay, so pay attention, it is only applicable for a second order matrix. Only for a second order matrix this technique is applicable. Okay, so let us say we have a second order matrix given by this. Okay, the four elements of the second order matrix: A11, A12, A21, A22. Now A11 and A22 are the principal diagonal elements. Okay, the first diagonal elements, and A12 and A21 are the other diagonal elements. Now the trick here is the adjoint. While determining the adjoint of the above matrix, what we do, the principal diagonal elements, they interchange their places here. It means A22 goes here, okay, A22 goes here, A11 comes here. They switch places, they trade places, they interchange their places. Now what happens to these two elements? They do not change places, they retain the same place where they were before, but they have their signs inverted. If they are positive, they become negative. If they are negative, they become positive. But the magnitude, the value stays the same, only their signs get inverted. So here we have is the adjoint of the above 2 cross 2 matrix. The trick is the principal diagonal elements A11, A22, they switch their places, they trade places, they interchange their places, while the other diagonal elements, they have their signs inverted. If it is a positive number, it becomes a negative number. If it is a negative number, it becomes a positive number. But their magnitude, it stays the same. Okay. Okay. So now let us just verify the shortcut method by solving the given example where we have to determine the adjoint of the given matrix. We'll do it using the shortcut method. Okay, so here, according to the shortcut method, this is the principal diagonal elements 2 and 5. So in the adjoint matrix, they will switch places, they will interchange their places. So the 5 will come here and the 2 will be here. Now these two will have the same magnitude values 3 and 4, but here they are positive numbers, the positive integers, so they will become negative, -3 and -4. So this here we have is the adjoint of the given matrix. The principal diagonal elements 2 and 5 interchange their places. The 5 came here, the 2 came here. The other diagonal elements 3 and 4, they had their signs inverted. As they were positive integers, they became negative, -3, -4. So you can verify it using the conventional method whether the two answers are same or not. Okay.